finding rational numbers from terminating decimal expansions. Now, earlier we have studied that the decimal expansion of a rational number results in either it terminates, or if it does not terminate, it absolutely must repeat. Now we know what is a rational number. Rational number is any number that we can write in the form of a ratio where both p and q are integers and q, the denominator, is not equal to 0. Now, I strongly encourage you to try as many rational numbers as you can and actually perform the long division, right? And find out for yourself that to test this theory, that all rational numbers, when you expand them decimally, it absolutely must terminate, or if it does not terminate, then it absolutely must repeat. The decimal expansion must repeat. Now, I know sometimes it is very hard to comprehend this because we have infinite number of rational numbers, and what we are saying is that for all those rational numbers, decimal expansion is only, it can either be terminating decimal expansion, or if it does not terminate, it must be a repeating decimal expansion. So I will strongly encourage you to test this out. Now we had asked ourselves two questions. So are there any decimal expansions that do not terminate and do not repeat? So we are going to address this a little bit later, but in this particular video, we are going to focus on if the decimal expansion terminates, or if it does not terminate but it repeats, then can we say, is it definitely a rational number? And the answer to the second question is absolutely yes. So for now, let's take a look at terminating decimal expansions and see if they are indeed rational numbers. So let's take a look at a few examples. Say we have 2.5. Is this a rational number? Let's find out. We can write 2.5 as 25 divided by 10. After decimal, there is one digit, so we put 10. Now, this definitely is a rational number because 25 is an integer, 10 is an integer. And if we can write them in the form of p by q, where both are integers, q not equals 0, then yes, this is a rational number. Let's write one more. How about 2.589? Is this decimal number a rational number? So we can write this as simply 2589 divided by, there are 3 digits after decimal, so we can say divided by 1, 2, 3 zeros, right? So indeed, again, this is a rational number. How about, let's do this, minus 15. I'm randomly writing some decimal expansions and I'm focusing on terminating decimal expansions. Minus 15 point, say 37, maybe just 37. Is this a rational number? Well, we can write this as minus 1537 divided by 1, and there are 2 digits after decimal, 100. And again, this is an integer, this is an integer, so this is indeed a rational number. Let's take a look at maybe a few more examples. Again, the focus is really on terminating decimal numbers here, right? So how about, let's do minus 278.511. Is this a rational number? Let's find out. Well, we can write this as 278.511 divided by, there are 3 digits after decimal, so 3 zeros. And again, of course, this is a rational number. So let us write one more, maybe 178.79795. I'm just writing some random decimal expansions, just trying to make sure that they are terminating decimal expansions. So is this a rational number? Let's find out. We can write this as 178.79795, right? Divided by 1, 2, 3, 4, 5 digits after decimal, so there are 5 zeros, 1, 2, 3, 4, 5. Again, this is absolutely a rational number. And let's do something like maybe 0.001. 506. Now, is this a rational number? Answer is, of course, we can write this as 506 by 100, and then this is a rational number. So what we are seeing is, if we are given any terminating decimal expansion, it will absolutely 100% be a rational number.